In this video I'm going to talk about the process of making histograms. Now in order to make histograms you're going to make sure that first that you have the stat pack available. Data analysis, it shows up under the data ribbon in the analysis portion. If it's not there for some reason within Windows, you can go to options and add-ins, and then the analysis tool pack. You click go and you'll see it there. So you click OK, and once you do that it shows up in the bar there. Okay, so first thing I'd like to do is talk about this spreadsheet. This is over a series of dates. We have stock returns that I'll just tell you ahead of time. They generally range between negative 30% and positive 30% for any given month over a period of time. The dates are a little bit messed up because of a sorting thing that happened, but they are month by month measurements of stock returns. Here are some summary statistics, and so we can see that for Cisco, that they have in one month they lost 20% of their stock value, and in another month they gained 30%. So let's see if we look at all of the months together, what the trend looks like for what they give, the return they get in a given month. So what we need to do is we go to data analysis, and we're going to go to histogram, and for the input range I'm going to select this column here. Now here's what's perhaps a little unique about this tool is it says you have to have the bin range. Now the bins are the columns, or not the columns, but the width of the vertical bars that exist. So you have to you have to think ahead of time about, well, how many bars do I want in my histogram? Do I want my data distributed out among 85 different ones, or do I want it split up in maybe 5 or 6? One thing that I've heard that is a good rule of thumb to start off with is 8. Because I already know that for Cisco the range is from negative 20 to positive 33%, I'm going to use these following bins that I've created. So if I click on this and I select here, what I have is a predetermined set of bins. Now one thing I can do is I can very carefully divide the number of bins based on the range that I have, but sometimes when I do that division, let's just say I divide my range so the difference between the top and the bottom number is 0.54, so I could divide that by something like 8, and if I got kind of a uneven number, that would be a little bit ugly, so I could just kind of round it up to some whole numbers that make sense based on the business problem that I'm looking in. Alright, so assuming I haven't messed anything up there, I've highlighted that range for my bins, and I will select labels, and now I need to have a place to put it. I'm going to allow it to be in a new worksheet, and I will call it CSCO, and I'm going to want chart output. So if I click OK, I get to go to a new page, and here's kind of the important stuff. Over here on the left hand side, I'm going to zoom in. It's created a table, and this table corresponds to those bin sizes that we talked about before. So this gives me a count of how many items were there that were less than or equal to 0.3, none. Between negative 0.3 and negative 0.2, how many observations were there in the data set? There were 2. Between negative 2.2 and negative 0.1, how many were there? There were 13, and that's how it created these vertical bars over here. Now we want to adjust this. So another thing I want to mention though is that it's these frequencies. After it looks at the bins, it's these frequencies that are put into this histogram. And at a glance we can already tell that around a 10% return is fairly common and if we mouse over it, it says 42 times that happened. And so compared to those other numbers, that certainly is higher. And there's a cluster. It looks like it generally gets positive returns because it's 0 or greater, and relatively few observations are shown on the left hand side. It looks like 13 there and 2 there, which we already know. So 15 things down there less than 0, but then the bulk are 0 or greater. Alright, so some things that are recommended that we do, if we right click on here and say Format Data Series, so just click on any bar, it slides in this thing which helps us get rid of our gaps. So with the histogram, it's recommended that you make everything join together. And so I can also resize it a little bit. And if it were of interest to me, I could also right click on here, probably less important, and I could change the font size to something that was more appropriate. But I think the most important thing is to change the bin size at this point. Alright, coming back to here, I mentioned that you have to create bins with a certain spacing in between them in order to be able to use that, fill in that box that says on the histogram options of where are my bins that I'm going to be using. And let's do this again, and this time we'll do it for GM. So GM over in this column, they have their range of data is 0.51, so from their lowest, which is 0.24, to their max, it's 0.27. If I wanted to do about 8, let's just see what the difference is between each bin. So I could do equals 0.51 divided by 8, so I could do a spacing of about 6%. So let's go ahead and start constructing this. I'll say GM, and my lowest value is negative 0.24. I'll start at negative 0.225, and even though I said 8 bins, I think I'll go a little bit different than that. This is, to me, is close to 5%, so I'm gonna create a few more bins than just 8 because 6 just seems like an odd number. So I'm going to take this number and add 0.05, and I'm going to keep on doing that until I get up just a little bit shy of this maximum value of 0.27 on the positive end. Okay, that's probably about enough. So now I'm ready to make a histogram for Cisco, or sorry, for GM. So I will go to Data, Data Analysis, Histogram, and for GM I'm going to select that column. Oops, made a little error there, went too fast. Data, Data Analysis, Histogram. Again, I'm going to grab that column. For the bin range, I'm going to use this, and for the output I'll put that on yet another tab that I'll call GM. Everything looks right. Alright, so there's my histogram that's been created for GM. Again, I want to fix the spacing here, get rid of the gaps. Certainly because I have more bins for this one, I see more diversity in my histogram. I can see more of the variation in the data and where it's happening. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bins technically. So that's quite a bit more than the 8 that I was originally looking for, but it's alright. Now, one thing that I'm able to take advantage of is the fact that I already have these descriptive statistics written here, but what if I didn't have those descriptive statistics? So let's just say I wanted like the min for Microsoft and the max. Maybe if I was going to create a histogram for that and I needed to figure out where my starting and ending points are. Well, I could go equals min and go over to the Microsoft column grab all that, and it gives me that number. Similarly, I can do equals max and do the same range. Okay, so if I were to then add those two things or subtract those two things, so if I were to take that less that, then I see that the range between those is 0.66. So if I wanted to then figure out how big my bin sizes would be starting at 0.34, I could go equals 0.66 divided by 8, so that value divided by 8. So I could just start at around 0.33 perhaps, or 0.34, negative 0.34, and start adding on bins in sizes of 0.08, and then I'll have about 8 of them available. Now the examples, so I have prepared some examples here of skewing, and skewing is this idea that instead of following a bell curve for the distribution of the count of your observations across a range of data, that instead it has a tail that goes off to the left or the right. And so based on that, we have a left skewed plot of data here. This one says days from conception to birth. It makes sense that most people are born at 280 days or more, and then with decreasing frequency it goes out to the left that'll happen. Family income, this makes sense that most, a lot of people probably have an average or a median income, or most incomes are probably around this number right here, around 70,000. But there's certainly going to be outliers, and so this kind of has a right tail. In contrast, IQs are known to be evenly distributed across the population, and so it has this nice symmetric look to it. Now, understanding how your data looks is important. Oftentimes in statistical analysis there are assumptions sometimes that need to be met, that some predictor variable you're using, maybe it's family income or days conception to birth, sometimes it's assumed that your data looks like this, and if it looks more like this or like that, you might have to do something to change it. Now, another useful thing related to these histograms is that we can use them to compare different observations. In this case, well, we're comparing Cisco to GM, so we could compare two different companies based on how their distributions look. And now I don't think that these two histograms are particularly good examples, but if you were an analyst, you could ask some questions like, which one is better if I was going to put my money into one company or the other? And we'd see that for Cisco that it's centered around 0.1, and then over here there are a lot of values. And then if we go down to GM, that it's not quite stacked up with the one above it, but at a glance it looks like the majority of its returns are from 0 to 10%, whereas at a glance it looks like we have a lot more over here. Now we'd actually have to stretch this out a little bit to get more verification of this, but imagine instead that these were offset dramatically. Maybe the GM its bell curve was way off to the left and this one was way off to the right. In that case, you could more easily distinguish between the two and get an idea about both the variability in terms of the returns that happen for that stock. So maybe it means one is more risky than the other and one is more predictable. And one just may be better because it's further up on the scale. So histograms allow us to compare data as well as to look for potential problems in our data.